Welcome to the open source adventure. Today we are gonna go over the Kafka network client. So let's take a look at the class diagram of the network part. As we can see, the producer, consumer, and admin client are all using Kafka client, which is the interface of network client to send requests to and receive responses from the servers. Network client can satisfy all the demands because it's flexibility. So for example, the producer is using a separate thread running the network client for producing records and handling the network I/O at the same time asynchronously, while the admin client updates the metadata itself outside the network client, which is a pretty uncommon practice. So from the class diagram, we can also notice that the network client is sitting in the middle of the application layer and the transportation layer. This pattern decouples the components. Specifically, the producer, consumer, and admin client is managing the requests, while the network client is managing the connection, while the selector is managing the socket channels. Now let's look into the two important public APIs in network client. The first API is send. The logic is pretty clean as shown in the flowchart. It binds the request to the Kafka channel but doesn't invoke any network I/O. The real I/O happens in the POL instead. The tricky part is that the user is always responsible for checking if the cached node status is ready before invoking the API. Otherwise, a runtime exception will be thrown. The common practice is to invoke ready API before invoking the send API, which does the checkings. Another interesting part is that the network client only allows one in-flight request at a time. It's trying to keep a one-one mapping between the node and the in-flight request. So when the network client receives a response from a server, it can tell the corresponding request directly without computing. If the prior requests fail, all the successive requests to the node won't get into the network client and won't get sent, which saves the networking and the computing resources. This won't impact the performance as the producer and the consumer request is packed into batches. Now let's look into the second API, POL. It polls the selector and handles newly happened I/O operations. If no new operation happen, the thread will block until the request timeout or the metadata expire. Users can always invoke wakeup to stop the blocking. These handlers are mainly doing two things, making the responses for in-flight requests and update the connection status in memory. The performance of polling is mainly guaranteed by the utilization of Java NIO. Let's dive this deeper in the next video. I'll suggest reading about Java BIO versus Java NIO. The one-one mapping between the node and the in-flight request mentioned previously also reduces the complexity of making responses. I hope this video can help you guys understand Kafka network client easier and better. The next time I'll go over the selector and explore how it utilizes the Java NIO. If you are exploring the open source world, please subscribe to my channel. Thank you, bye bye.